Hello everyone, my name is Huang. I am from the Department of Information Engineering, the Chinese University of Hong Kong. Today I'm going to present the paper, Understanding the Brains and Brawn of IllicitStreaming app. First of all, let's talk about the background and define illicit streaming. From the Intellectual Property Office of the UK government, they define the illicit streaming as the watching of content without copyright permission. It can be by any means. It could be hardware or software. In terms of hardware, it's usually called the illicit streaming devices. They are the physical boxes that are connected to your TV, usually cost around $300 per year to subscribe or buy one-off, and they provide hundreds of premium channels. And in many cases, these boxes are not illegal on the surface. They contain illicit streaming apps. When they run on top of the box, they provide illegal streaming sources. How big is the problem? In 2017, just in America alone, the survey tells us that it costs US $4.2 billion economic loss. In 2018, CNN has reported that in Singapore alone, the pay TV subscription of legal operator has dropped 15% in 2 years due to online piracy. In 2019, online piracy caused 560,000 jobs just in the US by the US Chamber of Commerce. And during COVID, the problem has increased by more than 60% in some of the country according to Interpol. Therefore, they launched a new 5-year Interpol Stop Online Piracy initiative to counter online piracy and this international crime involving intellectual property rights infringement. There are two observations. First of all, there are so many illegal streaming apps in the market. You just go to any app market, type in free streaming apps, and you'll find a list of them. Another observation is that after one of these has been taken down, another one just pop up in no time. We call that a whack-a-mole phenomenon. Therefore, we have an intuition. With such proliferation of ISA, would it be fueled by existence of common technical enablers that are helping the illegal pirates to build ISA, which is not a trivial application and infrastructures? Are there someone helping them to do that, which are common across different illicit streaming apps? This is we try to answer. In this paper, we have two contributions. First of all, new investigation. This is the first investigation into ISA in large scale. With these semi-automatic tools that we built, we try to combine software similarity analysis and network analysis to correlate different ISA and identify common technology enablers behind. From our case studies, we also find that there are new discovery which shows that common enabler of ISA does exist, which suggests a neutral point in fighting online piracy. Let's look at the architecture of ISA. On the left, you see the high-level block diagram of ISA where the pirates will take in or pirate the video sources from different countries and upload it to the CDN providers of the unlicensed video operator. Here in the middle, the operator will pay the video host for money because they are helping them to pirate content. There are many video hosts because they need a lot of premium channels to fit into the ISA or the ISD. And from the consumer point of view, they can go to any electronic market. In Singapore, Hong Kong is very common, and also in many parts of the world, that you can buy boxes that has hundreds of channels for a few $100 US. So they pay one-off payment to the box reseller and get the ISD. Sometimes the ISD has no software in the beginning, but the box seller will help them to install ISA and therefore providing a lot of VOD, video on demand contents, and live streaming. Without the box, you can also do that with ISA. The apps running on mobile phone smartphone or website, when you pay a recurring payment to this unlicensed video provider, which we will see in the subsequent findings, you can also get premium channels for minimum fee. And this is the high-level architecture of ISA. Our design of ISA analysis is this. We collect a lot of automatically crawl many streaming apps from the market, and also we upload some apps that we know are illicit, 21 of them, and also some of them are legal apps like Netflix and Disney+. We upload them to the same modules where we decompile the APK, we extract the features vector by methods level, and also compare them using the Jaccard distance to see how similar the ISA is with other streaming apps. And if we find streaming apps that are very similar to ISA, we will do a more manual and detailed investigation running on ISD or mobile phone, going through the subscription if necessary, browsing through the channels, looking at the network analysis requests from the ISA to the server side, and the output will be summarized in the JSON file. Our findings. First of all, as I say, we collect data from 21 confirmed ISA in the market that we know from media and reports, and then we download 10 legal streaming apps like the HBO, the Disney+, the YouTube, and then we compare it with 1,360 automatically crawled streaming apps from app markets, go through the same ISA analysis process. And here's our finding. First of all, we find that for the streaming application, obviously, we find a lot of video players. Besides, we have online advertising platform because there are so many of them that are funded by advertising on the traffic they generate through free content. And last but not least, data provided. The implication is that when we know the player, the developer's information, because of the library, we can find the developers. And with the developers, we can do a background check and see if these companies are really technical enabler with good intention, or they are in fact part of the content privacy ecosystem doing multiple roles. We will drill into that in case studies for video players' role. Secondly, for application that are serving advertising as a platform, they have like Mopop or Economy. They are viewing developers. They are the developers and they are confirmed set of ISA, which are illicit, like Terraria, BTV. They are confirmed ISA, but they also have a lot of these legal advertising platform serving them advertising, funding them. And these application advertising platforms are from companies like Twitter. They are big company. They have anti-piracy or trustworthy usage. But however, the execution is not done to the detail level. And some of these advertising platforms are placing advertising from brands like Citibank, McDonald's onto these illicit apps, which are not ideal. So it's down to the applications and the execution of the policy. So I think with these tools, we can inform the advertising platform to take down or stop serving ads to some of these illicit apps. And finally, there are data API that provides information from a YouTube video or Netflix video for good. But sometimes these applications, they offer metadata and images that makes these illicit apps like TV Zion here and Terrarium TV, they make them look very professional and real and user-friendly, but they are illegal. So this is something the data API provider could also consider looking at the background of these illicit streaming apps before they serve data. Another findings is that using our software similarity model, we can compare APK and we are able to identify potential ISA, which are developed the same way as we know from the confirmed set of ISA. For example, TTV is a confirmed ISA, which you can see here. You can watch all your favorite movies for free. And we find 4 similar applications. There are more than 33% similar. For example, BNTV Live is 68% similar to TTV. So we can sort out by the content owners which one to look into. If we know TTV is illicit, we can search the application market and find 4 more apps that are similar to them and look into details. Are they similar and provided by the same enabler? And could we take down them? Should we take them down at the same time? Another example is UB Live and UBVOT, which are coming from a very popular ISD called from the unblocked tag called the U-Box. And they, from the look of it, is a box with ISA. But if we look into the app market, we find that there are an app, for example, called VSAT. They are 94% similar to this UB Live. And at the same time, when we take down these boxes, we also look into their ISA and we find similar apps from the app market, and we know them if they are similar, and so we also look into those ISA and take them down as well. Look at the case studies, as we said before. When we find this ISA, we discover the library by our analysis, and then we could find sources from GitHub. Here we have an example of TV Bus. This is the library name. And then we look into GitHub, and we find that it is from a developer called the Binstream.io. We search the Binstream.io, and we find that it is a Shanghai company from China who is providing on the website P2P technology, streaming architecture, software and server, and demo player. But however, in the demo player, they are actually containing some official channels, not just testing channels. And when we look further, we find that these software applications are fully deployed in Super TV, which is an unlicensed operator serving HBO, CNN, BBC, and NHK, more than 100 unlicensed channels there. So here we know that from the TV Bus library, from the ISA, we find the library, we find their company developing them, and they are not just serving software, they are through the apps, but they are also supporting technology to unlicensed video service provider like the Super TV here. So they're playing multiple roles as a common enabler. Second case study, look at those two ISA again, and then we find there are Gemini libraries in the analysis after we decompile the APK, and then look into running them on the ISD. We find that they are making requests to the server side, which are also containing Gemini as a key path of the request. And then we Google the Gemini keywords, and then we find that it's actually a streaming services called Gemini IPTV, Gemini Project.tv, and then there are 22,000 channels, and there is also a client-side apps called Smart IPTV. So you can also subscribe here, or looking at the Smart IPTV app, you can purchase online from IPTV.shop for 30 euros for 3 months of 6,000 channels. 3 months of 6,000 channels for 30 euros only. And then you can also sign up as a distributor of their services illegally in different parts of the world. So again, Gemini libraries, the ISA lead us to the Gemini's libraries. We look up the network analysis to confirm that it is relevant server-side projects, and then we search and find the background of these projects and also other unlicensed video operating by and supported by these ISA libraries. Related works. In the previous related works, we find that in 2016 and 2019, there are analysis of free live streaming websites and also free live streaming sports sites, which are heavily have a lot of advertising, which are and potentially dangerous websites, and they track the user extensively. In our paper, we look beyond websites and target a new model, which is more common using smartphones. And these, to our best knowledge, is the first empirical study on common libraries or packages which are looking into the infrastructure of illicit streaming apps with scale. Also, in research in 2019, Panday is looking into infringing subscription websites, subscription services, IPTV services in the US. And the difficulty of this research is that they have to subscribe to different services before they can look into the network analysis and find out the common point. Our work actually make it more simple. We fill the void that there are so many proliferation, thousands of ISA in the market. Which one to look at first? So we'll fill in the void, study the ISA itself, correlate them with known ISA database that we have, and then shortlist the ISA that should be looked into first because they are very similar to the confirmed ISA, and they have higher chance that they are provided and enabled by the same group of enabler. And it is a simple and cost-effective method to bypass subscription and network analysis, which are heavily costly and human, or in terms of money, subscription, and also human resources of the investigator. So we make the process much more simpler and efficient. In terms of the software analysis, we look at, we are based on syntax-based similarity, which are similar to the previous work, but we also would try to extend it with semantic-based methods to see if that helps us to increase the accuracy of our application comparison. In terms of future development, we are focusing on Android and Java. We could look at Android and Kotlin-based and also iOS apps. We are focusing on English language store, but also if we look into Brazil, Colombia, South American, and China App Store, there could be more findings if we have these ISA. Actually, the same ISA could be in different names in different app stores for different language. So when we expand this search and download, we would be able to find more ISA that are correlated. Another thing is that we are looking in generic library, but actually malware is very common, and we can integrate our software analysis with malware detection and scoring systems to make it a further level of information to the investigator. And there are different technology to obfuscate the code, anti-debugging tools, but we can also integrate our tools with the work from others researchers like Death Hunter, the Obfuscator, or AutoProgram, which are helping us to do better analysis of the APK, even they are obfuscated. As a conclusion, our paper and our research demonstrates a new and scalable software similarity analysis in the identification of potential ISA. We help identify total 23 apps out of 1,360 samples that we collect from the internet, which are compared to only a small set of 21 ISA. If we have a bigger group of ISA, we will be able to find more similar streaming apps and therefore grouping them for content owners to take actions. So we provide insights before much more resource-intensive network analysis and human investigation and make the process more efficient and streamlined to tackle the whack-a-mole and proliferation of ISA in the market. In case of in our case studies of Binstream.io and Gemini, which I have described earlier, we have shown that common technology enabler of ISA does exist in the real world, and it shows them if we are able to group them and look into the background of this developer and see if they are also behind many of these illegal IPTV services, we actually help the industry, the creative industry, as a new method to tackle online piracy because there are common technology enabler. They are not just providing software, but also providing illegal content or making the ecosystem of the illegal streaming apps multiple and easier to provide to newcomer of illegal streaming. So we believe this is actually a new method to tackle online piracy with much more efficiency and targeted focus. Thank you very much for your precious time and attention to this presentation. Here I leave my contact for your kind reference. Thank you so much.